Hey, what's up? Can we solve every Monty Hall problem simultaneously? Well, let's see. So here we have a 1/3 probability of starting with car goat goat, 1/3 goat car goat, 1/3 goat goat car. And we always choose the first door just for the sake of simplicity. So Monty has behaviors in the scenario where we have car goat goat, he'll end the game immediately with x1 probability. He'll reveal the second door with x2 probability, that's what the 2 refers to. And he'll reveal the third door with x3 probability, that's what the 3 refers to. If it's goat car goat, then y1 probability to end, y3 probability to reveal the third door, and then for goat goat car, c1 probability to end the game immediately, c2 probability to reveal the second goat. So we got the x's for car goat goat, the y's for goat car goat, and the z's for goat goat car. So let's say that we are in a world where the third door has been revealed. And we want to know, in that situation, what is the probability of winning if we switch to the second door? So we are either in one of these two possible worlds here. And if we're in this possible world, then switching will give us a car because the car is behind the second door. If we're in this possible world, then switching will lose us the game because there's a goat behind the second door. So the probability that we're looking for is the probability of this possibility where we'll win divided by out of the probability that we are in one of these two worlds, because we know that that is the situation that we're in. So we have ourselves 1/3 y3 probability, the probability of the possibility where we'll win, divided by 1/3 x3 plus 1/3 y3, which is the total probability of all the possibilities. And this is going to reduce down to just y3 divided by x3 plus y3. So now let's look at everything all at once. So we have, if the third door is revealed, then not switching has this probability to win, switching has this probability to win. If the second door is revealed, then not switching has this probability to win, and switching has this probability to win. And if Monty chooses to end the game immediately, then we'll have this probability of winning. And you can get the classic Monty Hall paradox by choosing the right numbers. You could get the version where Monty behaves randomly, or any other version. We've solved all infinite variations of Monty Hall paradox simultaneously. Thanks for watching. See ya.